Hello students, this video is a continuation of the concept of Introduction to the Rewrite Systems. In the previous video, I had introduced only the concept of rewrite systems. So in this video, I will continue the introduction along with the concept of grammars. According to the definition of rewrite system, we know that a rewrite system consists of a list of rules and an algorithm for applying them. So we'll just consider the first part of the definition, that is the list of rules, and learn some concepts which are associated with the rule system in detail. Consider a set of rules as the ones which appear on the slide. S tends to ASB, AS tends to epsilon, ASB tends to BSA, BSA. These are the three rules which we will consider for our analysis. You can see that all the rules have got a left hand side and a right hand side. This is the left hand side of the rule and this is the right hand side of the rules. If you carefully observe, these rules are made up of some elements. Okay, you can see some symbols like S, you can see symbols A, B, epsilon, etc. So what we do is we consider uppercase. You can see S is an uppercase letter. Then we can have two more symbols which are in lowercase letters. So we consider the uppercase letters together. Here it is a S, and then we can take the lowercase letters which appear, that is A and B. We will not consider epsilon for time being. Okay. And using these two type of elements or letters which appear in the rules, we introduce two terminologies which are associated with rules. The two terminologies are non-terminals and terminals. What are these non-terminals? Non-terminals are considered as symbols which are required in the processing or working of a string. Whereas terminals are considered as symbols that constitute, or we could also tell as they make up the string which we want to construct. So we could tell S is a non-terminal, whereas A and B here are terminals. We'll see these definitions in detail with an example to understand it better. Now, we know that a rewrite system that is used to define a language is called as a grammar. And if G is considered as a grammar, then the language that G generates is represented as L of G. Like every rewrite system, every grammar has to have a list of rules. And these list of rules are treated as set. So it's an unordered list. Also, like every rewrite system, each grammar works with a set of alphabet. And the representation for this set of alphabet is V. And V has got two subsets. And these two subsets are the two terminologies which I introduced earlier, a terminal alphabet and a non-terminal alphabet. We also call it as a terminal symbol or a non-terminal symbol. Let us see the definitions of these two terminologies. We know that grammar is a set of rules which is stated in terms of two alphabets, or it comprises of two alphabets. The first one is a terminal alphabet, or you also call it as a terminal symbol, and it is represented by sigma. This consists of symbols that make up the strings in L of G, or the language of a grammar. The second type of alphabet which we have is a non-terminal alphabet, and this consists of the elements of which will function as working symbols that will be used whenever a grammar is operating. So these symbols will actually disappear by the time a grammar finishes its job and generates a string. So while we derive a string, the non-terminal symbols will be present, and once the string is derived, they disappear. By this we mean that non-terminals will be replaced by the terminal symbols. And among these non-terminal symbols, we also have another unique symbol, okay? And this symbol is called as the start symbol, and in most of the grammars, it is represented as S. If we do not have this symbol S present, then it can be any other alphabet also, but they will mention that such and such a symbol is a start symbol. When we go for applying formalism, we have to specify this following. We have already seen this, that is a form of rules which are allowed. So this talks about which form the rules have to be written. Next, we know that it should have an algorithm by which these rules will be applied, and we can also consider a third category is how the rules will be applied. That is, if we have more than one rule which can be used, if more than one rule can be used, then which rule has to be selected? To get the final string. So when we talk about formalism of a rewrite system, we consider three aspects, that is form of the rules, the algorithm, and the way the rules can be applied. Let us consider that we have a simple rewrite system R, and we have an initial string W, and we ultimately have to derive or obtain the string S. So we know that R can derive S from W. We have already seen in the previous video that this is a symbol which indicates the steps in a derivation. So we'll take an example in order to derive a string and see what is the concept of derivation. For example, consider that we have a grammar G, and this grammar G has got a start symbol S, and the rules which appear in this grammar are S tends to ASB and S tends to epsilon. So we'll take two examples here, generation of string. The first case is generating string AB. So how will we derive a string AB from the start symbol S of the two rules which are specified? So we can consider this as rule number 1, and we'll consider this as rule number 2. So starting from the start symbol, we cannot use rule number 2 here because we had supposed to arrive at AB. So we go with rule number 1. So starting with the start symbol S, we take the first rule, that is A, S, B. And we know that this right hand side of the rule, the symbol which appears, the non-terminal which appears here is S. So S can be replaced by either ASB or epsilon. But which is the rule which gives us this AB string? If you use ASB, then we will get AA SBB. So we know that this is a bigger string and we will not arrive at our expected string. So instead of the first rule, we know that we have to make a choice of the second rule. So if we use epsilon, that is the second rule, then we arrive at our expected string. So here we use rule number 1 and here we use rule number 2. Consider a second example that we want to arrive at a string AABB. So what do? We start with the first start symbol S and we take the first rule because we know if we use the second rule we will not arrive at the conclusion of AABB string. So S derives ASB. Now this non-terminal has to be replaced. So it can be either replaced by rule number 1 or rule number 2. So we have to pick up the rule which gives us the answer or which we read to obtaining the string AABB. So here we know that S has to be replaced by ASB rule and B. So here we make use of rule number 1. Here again we make use of rule number 1. Now the non-terminal which appears here in the second step has to be replaced. So which is that rule which will help us in obtaining the answer? So if we use epsilon, then we know that we will arrive at the answer. So we make use of rule number 2 and obtain our derivation, that is AABB. So this is how you go ahead or go about with the concept of deriving a string. There may be possibilities or scenarios where the left hand side of a rule may match the working string in more than one way. That is, match the right hand side more than one way. So we'll just see an example to understand this concept. You just consider that we have got a grammar G and this grammar G has got 3 rules. So I'll just label them as R1, R2 and R3. And it is specified that S is the start symbol. So we start the derivation with the symbol S. Here it does not make a difference because we have got only symbol S in our 3 cases, or we could tell there's only one non-terminal here. So we do not find a huge difference among if the start symbol is not mentioned. Let us begin the derivation like this. We take the start symbol S and we have taken one rule, which is this rule. This is rule number R1. And we have gone ahead with the derivation. So here we know that we have to replace this symbol S. So if you see the next step in derivation, we have made use of the rule ASB, and ASB again is rule number 1. So suppose we were to replace this S, then we know that we can make use of any of the 3 rules. That is, we have got 3 choices. That is the first rule, or we can use the second rule, or we can use the third rule. Now suppose we use the first rule. So we were here and we are supposed to replace this S. So if we are using this first rule, then we obtain a string like this. So it will be AAASBBB. And we know that again there is a non-terminal symbol in this string. So we'll have to go ahead with the derivation. Now in case we use the second rule. So in case we use the second rule, this S was supposed to be replaced, and you can see that we are using rule number 2 and replacing it. So the string which we obtain here is AABSABB. So we know that again we will have to replace this S and go ahead with derivation. If you were to use the third rule, that is, this S was replaced. This S was replaced by epsilon. And in this case, we have arrived at a string. So here, if we have used rule number 3, then we have to stop. But in case rule number 1 and rule number 2 was used, then we will be going further ahead with the derivation, and this goes on. So in order to stop the working of or the derivation concept, then we have to use rule number 3. So here, or this was a scenario which was talking about the left hand side matching the right hand side in more than one way, and there will be one rule among the rules which are specified which will help us in stopping the derivation. We shall take another scenario. Now suppose we have three rules like this. S tends to A, T, T, B. This is rule number 1. T tends to B, T, A. This would be rule number 2. And T tends to epsilon. This would be rule number 3. So we have, here we can see that we need to have a specification because we have two non-terminals, S and T. So it has to be specified for us that some symbol is the start symbol. And in this case, S is the start symbol. So you start your derivation with the symbol S. So since only one rule is applicable here, we take the rule number 1 and we have A, T, T, B as our right hand side. Next we know that we have to replace T, the non-terminal T, because this we have only the non-terminal T in the right hand side. But the confusion would be whether the first T has to be replaced or the second T has to be replaced. Let us consider that we are replacing this first T. And now when we replace first T, again we have to make a choice whether we make use of rule number 2 or rule number 3. So here it was rule number 1. Now we have to make a choice whether we have to use rule number 2 or rule number 3. Consider that we are replacing the first T by making use of rule number 2. So we have A, this T is replaced by rule number 2, so it would be B, T, A, and we write the second T as it is and the B. So we have made use of rule number 2. Now consider a scenario where we had replaced this second T. So it would be S tends to the same scenario A, T, TB, but we are replacing this second T with rule number 2. This was rule number 1 and now we are talking about rule number 2. So it would be A, T and B, T, A, B. Now if you compare these two strings, we have used rule number 1 in the first case and we have used rule number 2 in the second case. So though the same rule is used, depending upon the position of the non-terminal, we may generate, or there may be a scenario where a string is generated in more than one way and different kinds of strings are generated. So here we have got A, B, T, A, T, B, whereas in the second case we've got A, T, B, T, A, B. So using the same rules, we get different strings because of the position of the non-terminals. So this is also another way of generating many strings. Now when can we stop using the rules and deriving the strings? So we can tell that a derivation process may end in one of these cases. We have got three cases. The first case is where the working string no longer contains any non-terminals. So this is also applicable whenever we have a special case or whenever the working string is epsilon. Then the second scenario is where there are non-terminals in the working string, but none of them appear in the left-hand side of any rule. Though there are non-terminals in the working string, that is in the right-hand side, but none of them appear in the left-hand side of the rule. The third scenario is where both the first case is not achieved nor the second case is achieved. So we'll take an example each for all these three cases to understand the concept. Case number 1, that is when the working string no longer contains a non-terminal symbol, which means that we have arrived at the end of the string or we have derived our string. So I will take a set of rules, that is S tends to ASB and S tends to epsilon, and we are supposed to derive a string AABB. So we have already seen this example, so I'll be quick here. We take ASB, that is rule number 1. Again, this S is replaced by rule number 1, so it would be ASBB, and then I make use of rule number 2 and obtain AABB. So we know that this working string does not have any non-terminal symbols. Therefore, we can stop generating the strings. We shall take the second case, that is a scenario where there are non-terminals in the working string, that is in the right hand side, but none of them appear in the left hand side of any rule of the grammar. So we shall consider an example like this. We've got S tends to ASB, S tends to BTA, and S tends to epsilon. So I will consider this as my rule 1, this is rule 2, and this is rule 3. And we just take a random derivation. So I'll take the start symbol and I'll make use of the first rule. So it will be ASB. Now this S is replaced by the second rule. So I've got A, B, T, A, B. So the non-terminal which appears here is T. This is on the right hand side of the rule. Now, do we have T in the left hand side of the rules? No. So here, this is a scenario where we can't go ahead in the derivation and the situation is blocked, or the derivation is blocked. We call it as a blocked derivation. And we cannot generate any string, or we have gone ahead with derivation, but we were not possible to generate any string because of a blocked derivation. There may be a possibility where neither the first case nor the second case is achieved. We shall take one example as S tends to BA and B tends to BB. So this is our rule number 1 and this is our rule number 2. So if we were to start the derivation, we'll assume that S is our start state. So S derives BA. This B has to be replaced because it is a non-terminal, and there is only one rule which helps us to replace that capital B. It is rule number 2. So we have B, capital B, A. And again we have to replace this non-terminal B. So it will be rule number 2 itself. So B, B, capital B, A. Again it is replacing this capital B, non-terminal B. So it would be rule number 2, BB, BBA. Now you can see that this goes on. So we already can conclude that this derivation does not terminate. So can we generate a language here, or what is the language generated here? The language generated by the grammar is a null language. So we have seen the three cases when we can stop derivation, where we saw that in the case number 1 we were able to stop the derivation because we obtained the string, whereas in case number 2 and case number 3 we had to stop but we were not able to obtain the string. Therefore we can consider that in case number 2 and in case number 3 we had bad grammar. So to sum up, in this video we studied about the two terminologies which are associated with rules, that is non-terminals and terminals, where non-terminals can be considered as symbols which are required in the processing or working of a string, and terminals are the symbols which make up the string which we want to construct. And we also have a unique symbol in our rules which is called as the start symbol, which helps us to start the process of derivation. And derivation is a process of obtaining the working string, or the string which we want in our analysis. Thank you.